Retro coding live.
I'm not sure that was going anywhere. Let me gotta check. Hold on.
Retro coding live stream. Everybody scream. Retro coding live stream. Everybody scream.
Okay, well, enough of that. We're back. Microphone in face. What's going on, y'all? Got itchy head today. Alright. Try and groom myself a little bit for the stream. I've been really just kind of rolling out of bed and going straight to code land. And skipping hygiene a little bit, so typical coder. Uh, in this case, the bedroom coder, 1980s bedroom coder, coming back at you. Looking, I was just going through some of my code that I had to see if I had good examples of things to get when I get started on the assembly version of Snorky of my Atari game. Am I going to be able to jump into it easily? And there's a lot of examples of source code out there, so I can grab some. Star Raiders, for example, you can grab that as a source code, and that's all it's all there, everything you need. And they've got some macros in here, apparently, which is cool. Playfield expand, etc., etc. So yeah, this is all implemented in 6502 assembly. DTA must be like a byte. Dot byte is probably what I would use now. Um, that, or it might be another macro. I got to look into the macro situation. One of the things is, of course, there's all kinds of pre-built things. Now I'm jumping in. Excuse me, I just had a big glass of water. I'm gonna be burping again, but yeah, and a burger. So I'm fed and ready to go. Got all the fuel I need. But yeah, the code that I'm looking at has been a lot of 6502 and like different versions of different assemblers. And actually, I'm going to clean this a little bit. Space \t plus $sign as a yeah, there we go. Okay, so just getting rid of those trailing spaces. They bugging me. But yeah, this is Star Raiders. So if you've ever played Star Raiders, or if you haven't, you should go grab an Atari emulator and try Star Raiders, because it's really, like, for its time, it's amazing. It's just amazing. I mean, you're only fighting one ship at a time. Well, no, sometimes two. So but it uses sprites really well. It uses the background Starfield drawing stuff really well. I looked at some of the code and how it's working, and like, yeah, it's using the bitmap, which is what you want to do. It's using a lower resolution than you're going to use for Snorky. But you can get away with a lot with that particular platform. Anyway, it's pretty much anytime you work with like a limited platform, or put yourself in that mindset of working in 2D, always 2D. You can you get into an interesting problem solving mode. You have to think about special effects in different ways, uh, and of course when you have limited resources, like only 48K of memory or whatever. But of course with this stuff, back in the day, yeah, I talk about how Atari games were limited to like 8K cartridge or whatever. But of course that was just early on. And if they've very quickly graduated to disc-based games, which were much larger, and which had compressed data on them, and which had multiple discs, and which had much more scope and scale. And you can look at examples from like Electronic Arts, like what's that one? Uh, Seven Cities of Gold. Remember that? That was sort of ambitious for its time, but that's the general gist. You could make things that were, that one kind of. I think if I remember right, it limited the playfield to a really tiny area, so that it didn't have to draw as much. So it was optimized in its own way, but Anyway, so right now I'm looking through this old stuff to get some of that wisdom, some of that optimization wisdom. So Star Raiders is a great example of how it, what it's all about. And the only thing I would do with this is it's probably just a dump. Yeah, in fact it is. This is a dump of Star Raiders.s. There might be a cleaned up version. I'm sure there is somewhere. This is the XEX file, which, I don't even want to bother to look at. Here's the source code. Maybe it's a better version. Original bin, link list, LST, header bin, RE by Lauren Weist. So I think this might be the cleaned up version. Yeah, reverse engineered and documented. Oh, but at the same time, as much as it's reverse engineered and documented, like you can actually use line numbers. In the original assemblers, we would use line numbers back in the day. So these are actually, if I look at them, yes, they are just numbered 1 through whatever. Those are not memory offsets, thankfully. So this isn't a dump. It's a cleaned up version where you could put it into an assembler that takes line numbers and it'll be happy with it. If you want to get rid of the line numbers, that's easy enough to do with a simple regular expression replace on the whole source code here. But in general, as I'm looking at it, this is much more documented. Yeah, everything's got names, like skip here, BNE to skip, shield color, clear playfield, JSR clear playfield, store. So this is a nicely documented version of Star Raiders. So you could study this to see how to do really good bitmap manipulation and so on. Like essentially, if you wanted to have something where you say, I just want to, do a draw at XY with, X in a particular register and Y in another register. That's a good way to do it, and that makes it very speedy to do that kind of thing using registers. So you kind of decide what how your functions are all going to work, and these things are built up piece by piece. I can't imagine what it was like to build this thing, but they brought it together, and I like how they have all the data for the Starbase all described here, and where it is in terms of memory and stuff. How long is it? That's a full 16 or something lines. I don't know what it is, but it's a lot. Yep, 16 lines of data down to that. All the different sizes are represented, and of course things can be mirrored with your graphics, so you gotta keep that in mind. If you can save space by mirroring your data, then you're in good shape. So all these tricks are used, and this particular cartridge is, I don't know how large it is. Do we have the link file for it and stuff? It might mention how large it is. I think it says A00 size 2000. So what is that, 8K? So yep. So very cool. Great to have. I totally study this for understanding how to do an Atari game at this level. And this is one of the most unique ones because it really kind of set the stage for, oh, this is like, high level, set the bar high for what a game could look like if you decide to make yours. And then a lot of people, made games, but they ended up being very, cubey and square and based on character graphics or, but in essence, if you look at all the work that was done, there's just so much great work in the world of Atari games and Commodore 64 games. And again, at that high level, they're disk based or basically just use as much memory as you want and have it bank switch. These days, you have so many ways of making bigger, more interesting games using different platforms and having different styles. I like the limitations that this places on you, so that's where I'm jumping in. Earlier, I was working on some Marlin stuff, and I was getting so bored, but I cranked on a few things and got a couple of pull requests sorted, so that's a good start. I really need to jump into bug reports just ahead of release and fix a few things, whatever last minute things there are, especially in the UI. The UI is always a challenge because you don't get to test everything on every feature, but I should have a few representative ones and really run through them. Uh, have a checklist that I go through. Surprising, I don't have a particular checklist. I just kind of wing it, but in general, it's like I rely on the community to do a lot of the kind of voice testing that we do. Uh, but overall, you know by making very slow and methodical changes over the last few weeks, and uh, making we know what the issues are. We know what issues we have. I guess you could say. Um, to last things to bite off, but yeah, pixels bite off, baby. So anyway, Star Raiders, check it out. Um, I could load it up right now. It would be fun to play it, but it's been a while. I actually have a nice. Is it retro coding? Open EMU ROMs. Um, for the Atari 5200. But all the various versions of it, the original is still and forever the best. I don't know how they made it so good, but there's an Atari 50 there's an 5200 version of it. I believe there might have been even a 2600 version of it, come to think of it, which was pretty impressive if they did pull it off. But you can imagine, yeah, they did. So that's a smaller scale, but very cool game, and all the things that did a fair job. But the original on the Atari 800 is still by and far like it sold a lot of those computers. It really did. Uh, it was that, and then later on, other things, maybe Pac-Man or Defender or other cartridges that came along. But that was the one that like early on was like, yeah, do you want to get this for this much or this? And they were pricey at the time. They were not cheap. Anyway, uh, could open that stuff, but I'm not gonna. Let's see, where was I? Oh, because I wanted to get back to. I need to find some tools. That's kind of why I'm here today. I was looking at Atari Dev Studio in the Visual Studio Code, which is a plugin. If you go searching for Atari, you find various things. There's Color Theme by Philip Goluski, and there's a syntax, which, by the way, I helped make. Apparently, it's got a little thanks to me in it. Um, so a pretty cool one. A little Atari Basic syntax in here. I have to get this sorted out so that it displays Atari Basic the way that I have it set up in Sublime, and then I can also make a little workflow in here for Atari Basic, and I wouldn't mind doing it as a part of Atari Dev Studio if it hasn't already been accommodated. But let's take a look at what it gives you as features. It gives you extension build game for compiling source code, and it does different things. I think it's more. Oh, it does have a sprite editor. I did a sprite editor once, and it had animation features, and I kind of liked the way I did it because I had it where the sprites were side by side, because you can have 4 side by side in player missile graphics, or even 5 if you use the player missiles again, or the missiles as a sprite. So if you're just doing the 8-bit wide ones, you can have it set up that way. So that was what I did. I put them side by side and had a little frame drawn around them, and uh, then I had a little section for drawing the one you had selected, and then but it was like you could go through many frames and to the left and to the right, and they would continue. So it was basically, and I never did a scroll bar, but that would be a cool thing to kind of have in there, is like how many frames, and give you a little scroll bar indicator. That wasn't really a um, convention at the time, but that would be something, use some of the modern conventions. But anyway, going back to what I really am looking for is something to edit sprites with. So let's take a look at what we have in the world of, at least on Mac OS, within VS Code, Atari Dev Studio. So it gives me some commands, and it gives me some settings, and the settings are, it uses WASM for compiling stuff instead of I don't know if it's instead of DASM or just in addition to DASM. it does do DASM, so it has DASM args. It has Batari Basic, so those are set up. So as long as you get it all set up with all the things you need, there was some project that I had contributed the Mac binaries to that didn't have them built and included in the project in the project. So I think I added those and maybe I don't know if I tweaked the make file or anything like that, but one of these things I helped out a little bit with that. Uh, it might have been the Atari Basic main project, come to think of it. Well, anyway, hopefully that's all working now. We needed to be able to build. So there's cool, and then 7800 console and so on region. Normally when you look for these settings, you just go here. So we go to the extensions and we go down to Atari Dev Studio, and there they are. So can we zoom on that? Yes, we can. On startup, validate the runtime, show welcome message, what arguments to 7800 basic. I forgot to, in my last stream, I was thinking about how Batari Basic was like sort of neglected or whatever, but it's not in the sense that 7800 Basic is a fork of it or an extension of it that brings kernels for 7800, which is, we're talking, much higher level stuff like that than a 2600. It's 3 times better. But anyway, so you have a compiler for that, and so I would install. There's instructions on Atari Dev Studio's page, and probably on that in here on how to install the pieces you need. But and there be nice if this included something. I know it did include. I think it didn't when I started up earlier. It did install WASM for me, or parts of WASM. So, and then Batari Basic, which one do you use, and default, and I think it brings its own, and you specify DASM args. So that kind of stuff you don't have to really worry about. The one thing I would do is just like look at what code is being used for its Batari Basic, because I was curious about cleaning that up and making it better, because I remember it was sort of like, it wasn't the best looking C um, code, but I think what they're doing is they're doing a build in C, and then for I'm just winging it here, so don't quote me on this, but I think what they're doing is doing a build where it's like converted, so it's not like they're doing any change to the source code or maintain or keeping the source code as part of this. I think they're just using the binary and rebuilding it in a form that can run inside JavaScript land. So anyway, I could be wrong, but we can look into all that and how this is all built eventually. But basically, I'm only here to like, I can help out, with some of this Atari Basic stuff, because that's one of the things I notice is not here. Is like Atari Basic is not really one of the things that's considered. So that's the one thing I would extend this with is like, let's get some Atari Basic in here. And I guess I'm the guy to do it because I have all the pieces and I know how to do these kinds of extensions. So the one thing as I'm afraid of is it's all probably done in TypeScript and it's ugly. But I don't mind getting into TypeScript if I have to. Okay, so anyway, there is an Atari Basic syntax, which is cool. Restart extensions. So if I open up my project and I open up an Atari Basic, and let's say just Snorky, why not? Close this. Boop. It is now active. WASM time is complete, so it did that. So cool there. Hide that for a second. There we go. Yeah, so it does have the syntax apparently. And this does notice it just does know it's Atari Basic, so that's cool. Now the only thing I need to do is get it to use the right font with this syntax. And I don't know how to do that. Let me see if LM Studio knows something dumb like this. How can I cause use a certain font with a certain language in VS Code. There's probably an extension for that, but I just don't know what it's called. Or how can I automatically cause VS Code to use a certain font with a certain language? There we go. Boop. So, or even a certain theme, I should say. But let me get the theme here. Hold on. Set the color theme. Sorry, XZ. So at least we get the right colors now. There you go. Gotta have that. So this kind of, again, I was thinking I should do the same treatment that I did for this for Commodore 64 Basic. And make a syntax for that if it hasn't already been done for Sublime. I know Sublime is one of the more pricey editors. The free version doesn't limit you, it just nags you. But it's worth getting if you use it a lot. But as in terms of this kind of stuff, it's also very nice to have it as a, it gives you an instant, basically hooks so you can make a keyboard command to build with it or whatever. So it's kind of nice. And in the same vein, you get a lot of power with extensions in VS Code. So let's go to that. Let's close the settings. And I don't need to run any of those things. I can fantasize about adding to this later. For Mac OS, apparently I need a 64-bit OS to use this because of the SDL libraries, etc., etc. Makes sense at this point in history. So, okay. So given this and the other thing, how do I set the font? Editor font. I guess that's one of those things that's probably a setting. And it'd be nice if I could set it for a particular language, that's the thing. And there's not a way to do settings, say, per language in this, per se. But maybe there is. Settings, themes, yeah. Theme doesn't come with a font. So anyway, you see what I've got here. Atari Basic has that as a separate extension, which is nice. Reuse the terminal. And needs to know where the emulator is. Interesting. So yeah, I don't know, Atari Dev Studio might not even have that. It's mainly aimed at 2600, 7800, it looks like. So as I'm looking at it, there's the 7800, there's Atari Basic, which is 2600, but not direct 2600, and then DASM, which would, if you're doing 2600, you should be using DASM probably. But also you should consider using all the headers and stuff. But if depending on what your needs are, you can write most of what you want to do in Atari Basic. If you run out of the steam with Atari Basic and you need to go further, take the assembly that it spits out and start from that, and then go forward from there. And hopefully, with luck, if you're doing 2600 coding, you'll get there. It's a tricky one to keep going and keep alive because it is a hassle to learn and get used to its weirdness. But the examples help, and you can get far with just using Atari Basic. So yeah, sure enough, Atari Basic has some things. So if I want to run this in Atari Basic, I do it. Atari Basic run. Look at that, there's a thing there, it'll run it. Atari Basic run dot not found. Oh, is this something that I started and I didn't finish? Or is it started in that particular extension and not finished? Because it's certainly, it does exist, but maybe it doesn't exist in the plugin. So the resources, if you want to look into this, here's the repo. for this. And as you can see, here's some example code. It does some nice Sublime syntax coloring on it. It should anyway. Well, there's that one. I guess there may be two separate ones. One of them is part of Batari Basic. The other one is Atari Basic. The other one is Basic, which is definitely not right. I don't know. There's a lot to explore here. But in general, this is why I prefer doing editing this in Sublime for sure. So we won't bother too much with that today, because we know what it'll look like pretty much once we get the font set in there. But I don't want to use that everywhere right now. So hopefully this will all work out more interestingly later. So in the meantime, what I was looking for was the Dev Studio, or let's see. I want to use the background builder editor for 2600. What? There's a 2600 for that? I mean, a thing? Well, there's probably some online tools, come to think of it, for this kind of stuff, but I want to see what commands Atari Dev Studio provides. So it provides something. Hello? Atari Dev Studio, give me elements. Okay, there's a sprite editor, there's a background builder, and there's a player pal editor, all for 2600 type stuff. So, not really something I want to use. So that one is really aimed at those particular platforms. I don't know if Atari Basic is even appropriate to include or with those. I think it's probably better to extend the Atari Basic plugin, or even, I'll build my own and then work with what's there and collaborate on that a little bit with the original author. Cause I sure know I want to be able to do Atari stuff. There is also a fast. Oh, I was talking a little bit about other basics. Fast Basic is another one that is an example. And if you look at this, it's very different from what regular Basic was like, because you got do, loop, you've got, blocks. So you don't have, and your line numbers, no line numbers. These are just the line numbers from the editor. So yeah, it's just nice, very nice. It's much closer to, the type of Basic that you would call, I guess you could say that Atari Basic is closer to this type of Basic. But it also has very nice expression handling and stuff, so that's nice. So what else we got? Fast Basic Debugger even. Check this out. I don't know if it's actually working, but it might. But it uses Atari MacX or Altera. Runs the emulator with a single key press and all that kind of thing, which my current command doesn't in here. So again, I can't just run Atari Basic in this thing yet. I don't know why. Also, which things do I actually have enabled? I have the syntax enabled. I also have the DASM enabled, macro assembler, which, it's pretty cool. It does nice stuff. Processor 6502, etc., etc. And I don't know why these are org. I think they would be byte or something like that rather than org. But anyway, at least as I understand it, unless they've redefined what org means. Either way, pretty cool. Nice to have. It does the things you want. Assembling 6502 code. So what we're here to see is finding an actual decent sprite editor. So let's look online. Atari 800 sprite, or we'll go player editor. This is the thing I tried to make once that I just described a long time ago. Here's one from Atari Mania. So we can just grab this and use it if it's any good. Let's grab it. Oh, it's apparently a PDF version. We might have to type it in. Or is there a disk? Nice. I like it. If you want to see the disk, here's a picture of the disk. But yeah, so again, loading player missile editor. Hello? I don't know if I'm not going to go searching on there for that kind of thing. Just the search terms in their search engine doesn't work so great. Max65 assembler editor. I used the assembler editor that Atari made was pretty good back in the day. The macro assembler in particular. The assembler editor wasn't bad, but the macro assembler was like first class, really good. It was a little hard to get used to because it was all keyboard commands, little one-letter commands and stuff. But once you got used to using them commonly day by day, they were pretty cool. Oh, look, a new Atari sprite editor. Nice. That's kind of exactly what we want, right? Runs in browser. And look at all these phone sprite files, SPR files. Cool. So what you really want is something that can export. And look, there's the page. There you go. That's what we were looking for. Yeah. So you want to be able to export to some format that you can use in your program. So there you go. DTA. You know, MADS assembler, Max65. I would be using CC or CA65, which is not shown. Yeah, see, there's your C compiler. Now, I could be doing this stuff in C, but that's kind of in a way, that's a step backward for me. Because normally what I would do is I would implement something in first in BASIC. I'll go, okay, this is now done in BASIC. Now here's how we do it in assembly. Or no, this is how we do it in C. And then we would go, okay, now here's how we would do it directly in assembly. But it's like in C and on the Atari is so close to assembly that you might as well just use assembly. But there are some great things about assembly and great things about C both. Of course, you know, being able to refer to structures and have things automatically increment and having types like pointers and all that great stuff in C that takes all the work out of things is great. But the good thing about working in assembly is like if you know the carry is guaranteed to be clear, you can remove one instruction and save a whole cycle, you know. And that happens so often, and you're like, okay, well, I got it down to be small and efficient, so you know, or fast enough. So you got fast basic. Here's good old basic data. So that's kind of where I would jump in. I'd be like, okay, here it is in basic, yeah. So I'm going to be using basic. So this is exactly what we want right here. And it's not even any particular version of basic. It looks like it's just data, REM. So it could work on Atari. It could work on whatever. So these are nice. So cool. I don't need them to be much taller. So let's draw our character who's going to be called Snorky. Yes, that's right, Snorky. So I don't know if I have to hold shift to yep. Shift clears and unshift sets. So let's draw our character. So first off, he's got to have little feet going off in one direction, and then they come up like this. Also, the way that these things are centered, 7 bits wide makes sense for this character. And the way I originally drew him was with a long nose like Kubert, but kind of going off, and that was like the shape of his head or something like that, as I recall. I haven't not drawn this character. I have not preserved this character in any way. So this is what you see is what you get here with this little guy. So was this Snorky? I don't know. It looks a little bit like him, but he could be a taller, I suppose. Maybe he had a little mouth to differentiate his snork from the rest of his face, but that's kind of what you got. There's our snorky guy. We could have him look like that. And yeah, real exciting. Now the thing with sprites, of course, on the Atari is that we only have a certain number of color, which is to say one, unless you overlap them and combine them. So I was thinking about it overnight, and I was like, well, maybe at a certain point I should look at using bitmap graphics and exploring how fast those can be on the Atari. And they can be fast enough. I mean, there's a lot of you look at something like obviously Star Raiders, and it's whipping out those pixels really fast. So you can imagine that a game that just has to have a few little multicolor characters jumping around can be pretty, you know, pretty snappy. So you don't have to worry about pushing that many pixels. But it all comes down to, and the other thing is with the way the bus works on the Atari, it's like you don't have to worry about things like caches being invalidated and stuff. It's just like all your memory accesses are cost the same. So it's just a matter of you know optimizing by having your uh, the things you're doing happen in little loops or whatever. So okay, anyway, and this one you can add sprites. Check it out. You can add frames. So let's add a frame, or actually let's delete the frame and then clone the frame. And then so this would be like our little dude is jumping. Check it out. Woo! I would change my frame rate somehow, but all right, stop that. So, but basically, then you can do other operations like on this. You would want to be able to have it move up. There you go. So that could be, the dude gets taller. Boop. And then clone. You do this kind of thing. Nah. Boop. And then let's see. Might do something more like this though. Hmm. Getting weird with this. Boop. Nah. Was there like an undo on this thing? Undo. Boop, 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 boop. All right. Anyway, so yeah, you get one color to work with, so you can pick it. What color would I make my guy? I was going to make him green, actually. Cubert is orange, my guy is green. So that makes him way different. Way different. So there he is, green, and also, yeah, I guess you can have him change color on a per frame basis if you want. And I guess, oh, there is a way to use multiple colors with these, but unfortunately, I will not be using, like, here's the basic version, 0062 127. That seems possibly okay. 127, is that right? Yes. Okay, so yes, this seeing it as a 1-bit thing in the export, so very good. Excellent. So anyway, color, I don't know, I can't decide. We'll figure it out later. So that could be one of his some of his frames, and then of course you got to have him like face the other way, um, and stuff like that. But I don't remember how I made his nose more interesting. I had, it's like I'm saying, I don't have a lot to work with here, so um, hey, cut that out. Hey, cut that out. Wonder if I did it like that, something like that. Just like kept it more low profile. So he's got like a little more of a beak or whatever. But this is the look I'm going for. Also, he's not supposed to be. I forgot also that the resolution is supposed to be not like vertically is going to be squished, like compared to horizontally. The pixels are actually wider, so I can't really. I guess that's not an option with this. Oh wait, maybe it is. There's an options button. No, not square pixel, please. How do I make it not square? It's got to be a way. NTSC. Give me NTSC. Common palette for all frames. Show grid. DLI mode. What's that? Display list interrupt mode. Um. Equals sprite width. It's not doing. It doesn't give me anything for non-square. Sprite height. Wait a minute. 16. Good. Well, at least we have that. Merge mode. P0 plus P1. Player missile 0 plus player missile 1. I guess. Missile player 0. Missile player 1. I'm not sure. It's cool. It'd be cool if it could export some code you could actually run like right away that would display it on, say, an Atari. But it wouldn't be too hard. I've been making little throwaway bits like that recently for use in compiling and testing. It's part of the makefile, in fact. I showed it off yesterday. Show bytes as hexadecimal prefix. Darn, there's no like. Oh wait, one line. Yes. All right, now we're starting to get somewhere. So yeah, I had a different resolution to work with, so I had a way of like kind of. Yeah, there we go. Now we're getting somewhere. But I'm pretty sure I made his nose just kind of like pointy, like whoop. Originally, I don't know why I'm trying to even do the original look, but thing I could do is like whoop, make his eye open a little wider. No, that's kind of silly. But even giving him an eye, I don't know if that's important. Yeah, I guess it is. Got to give him some kind of like little eyeball, even though it's gonna be hollow and you'll be seeing through it essentially. It'll work, I guess. And what do we got going on here? I guess I do need to flip it horizontally, so let's clone. Can I just drag it? Nope. Do it that way. Flip horizontally, then clone, boop. Flip horizontally, then clone, flip horizontally. Boom. I think that's that. So, okay, so what height do I want to make these then? And I want to move them all up by a certain amount, and I don't know. Just throw them in the game for something to play with. They're obviously very simple at this point. You could add a lot more frames and so on. The idea also is to like reuse parts and not oversaturate your. But we got a lot of memory to play with for now, so no big deal. So let's start it by moving them all up by 1. And then setting their height all to 3 less than that is now. So options height 13. Sounds good to me. Okay. So they'll stand up a little above the cube surface and all that. Oh, then I need to have like the other thing too is I need to have them face 4 different kind of directions basically. When jumping up, he's facing up and away, and yeah, it's gonna be a little tricky, but maybe I might have only done it with just 2 directions originally when I'm thinking about it. He just lands and like stays facing the direction that you left him, or until you know, as you move the stick or whatever, he just changes direction in that as you move. So we'll check it out and see how it looks. We can keep it simple for now, and the idea here is to have him, I don't know, he kind of looks like a flea. I know, I should just call him Snork Flea. But anyway, we'll see how this goes. Alright, so let's copy the export to basic here. And it's going to work for us. What's with all the extra zeros, I wonder? Is that because they're like bit planes? And then those other ones are 236. So, I don't know. Maybe this is all I need. Just this. 1, 2, 3, 4, 5, 6. Interesting. I feel like this is all the sprite data, is just this stuff right here. 1, 2, 3, 4, 5, 6. Yeah, let's copy that part. Alright, let's put it in our game. Boop. Back to love you, Marlin, but it's time to move on to much more important work of Snorky. And another swig of coffee. How are we all doing tonight? Everybody feeling good? My cadmium phone is running out of battery, so retro and Marlin today. That's what we're working on, all the things. The retro things and the Marlin things. I don't know if that'll get us charged. Hopefully. Hopefully so. Okay, moving on. We got Snorky. We got some data for you. So I think I'm gonna put it into. Maybe I can put it into the Snorky move. So I was gonna do it this way, like. You can see what I'm doing. So we have the sprite data down here at the end. And I just used some very basic stuff, but here we go. Here's a sprite. Now if I'm just doing move on this, or not replace, I think we're gonna go. I think I'm gonna go with copying this and making this instead of Snorky move. I'm gonna reveal this in the Finder. I'm gonna duplicate it. I'm gonna call it Snorky guy. We're like player avatar. I don't know. I'm partial to Snorky guy. So basically, this is gonna be Snorky guy, and this is gonna be Snorky, and you're gonna tell it basically where itself is, so it can point at its own sprite data. You're gonna tell it what sprite you want to put it into. You're gonna tell it. We don't need to do the size stuff. We're just gonna tell it the X and the Y that we're gonna be putting it at, and I don't know if we should keep the old Y and new Y, because the old Y is like, you know, kind of like you have to clear it. I'm trying to think of how to do this. I don't want to necessarily have to clear the whole sprite and redraw it that way. I'd rather redraw it from where it used to be. And having the old Y, it would be helpful to be able to do that, to be able to erase the old one before I draw the new one. But I could also just preserve the state somewhere in some, I don't know, memory location that is handed to it, like a string, for example, address that could be used for storage. So it's one thing I could take from this as a place to store stuff. Would be give me a place to store things like state. So that's another cool trick you can use, which I haven't explored, but you could just use another string pointer that is where the state goes and where everything else is. But anyway, sprite data. So we're going to just go with sprite pointer, or we'll go with sprite address here. Sprite address. And XY and data, huh? And also direction is one of the other things we need to pass. So yeah, it's a little interesting. So we want to know which of these we're going to be drawing. So let's do our sprite thing. So we're going to do it this way. And if for this, I don't know if that thing exports to assembly. Maybe it does. Maybe it already does that. Max 65. Yeah, this could work here, just using that byte. Other assemblers, byte, fram. So yeah, that's another way to do it. Just have the pointers to the sprites as well. But we can't really use pointers, we can only use offsets. So we're going to basically be treating them all as the same height and just use a for easy offset. So let's copy those bytes and do it that way. Back to here. So we'll use these. Yeah. And we just say byte, and then we have the bytes. So we can also say, yep, do it that way. And we don't need to necessarily know the sprite data, but we could do it. We could also do, we could do this kind of thing. Sprite size for an individual one or whatever. Frame size equals that minus sprites. So we now know that it's whatever, 13 bytes. We can just have that. With these assemblers, it's kind of nice. You can define stuff with down here and then refer to it at the top, and it's fine with that. Doesn't care. Because it does a 2-pass on things, or as many passes as it needs to do to get all the symbols resolved until it either gets no new symbols, and there's, you know, if it gets new symbols, then it's it fails. But it will stop trying if it got all the symbols it needed, of course. Snorky guy. Um, so here we are. So how are we going to do this one? So with this, we just want to draw one of these 13 bite-sized frames here. So in order to do that, in order to multiply by an unknown number, you typically create a macro for that that does the appropriate number of shifts and so on based on the value. And it's pretty clever. Weighted, you can do it pretty. I've done it before, and I would do it again, but I'm not going to do it today. I'll just assume that these are 13. So I'm going to be multiplying by 13. 12 would be easier, but 13 is fine too. It'll give us an example of multiplying by a odd number. So we're going to have that, we'll have that, and we'll have the direction, and that's pretty much it. And as far as where the x and y is referenced to, usually it's in reference to the position on the screen where the snorky guy is like supposed to be standing. So in that case, we're going to subtract something like 13 from that, and so on. And we can modify these frames as we need to. And we know that we've got this many too. We can say these are the left sprites, and these are the L sprites, and R sprites, and sprites in general as well. Why not? So we have all that kind of thing going. Now, we'll just call it Snorky Guy. Snorky Guy. Procs are optional, but they're fine. I'm keeping them around just to remind me that they exist, and if I want to use them, I can. So for Snorky Guy, we're going to be, in this case, let's follow the path that we followed before. With cube, we got the data address using an offset, so we're going to do the same thing here. We're also going to we don't need to necessarily know the number of arguments in this case, so we might just skip that. So here we go. Snoop. Guy, Snarky Guy. Okay, so first off, we're going to need to know, we're going to need a pointer to Guy. And we'll need 2 bytes for that. And then this will just be we don't know what those will be yet. So we'll just call them our reserved. P guy will be pointer to the guy. And this also is going to be 1 byte, I guess. So we're just going to use the 7 that we know we have. And for now, we got 1, 2, 3, 4. Yep, sure enough, 5. But we're going to go here. We go transfer argument to X, then we get the address of this user, and then we get Snarky Guy and sprites and store that in P Guy for now. And we could multiply that frame by 13, so we could put that in right away. But first we want to get the address of the sprite. So sprite address of, well, this is going to be the sprite address of the, we could put it there, I guess, since this is kind of like the source. So we could say source is this, is yourself plus whatever your direction stuff is. So now we get now we'll get those and we'll add them in. So I did a multiplication earlier by 40 in Snorky cube. So we'll look at that again. We will not be using the screen low and high. We'll be using the sprite low high. So we should get that too. I forgot that part. So p top is the top of the player. So we store it in p source. Let's see. See if I get this straight. P top is what? What, where, who? Oh, it's not mentioned here. It's mentioned here. All right, so yeah, p top here is, boom, get the address of, we're gonna need this. We're gonna need this destination address. We got our source address and we got our destination address, or at least p top anyway. And then we're also going to have a y offset address value that we're going to be keeping track of as we go in this multiplication addition thing. Or I guess not. We won't be needing it because we're there 1 byte. It'll be a 1 byte one if anything. So we'll just be adding it on, I think. Well, we'll see how it goes. But p top, and I could just say p, well, that's the multiply by 13 part. And so let's do that much. So the first thing we do is get the address of this user, and then we point p guy, and then we need to get the frame number. Okay, so we got that part. Now we need to get the frame number. So let's do that part. Oh, we'll also need the right address will be p top. Should probably just say pspr or something like that. Let's do that. Or did I call it sprite? Yeah, I keep calling them sprites. I'm gonna have to get used to that. Let's just call them sprites for now. That's what we call them in modern days. So in general, we keep it separate from player missile. So storing p size. So we're not going to be needing the size. Let's see what we got. Direction. Okay, so now we get the direction in, let's see, here's a good place where we would do it. We know it's only going to be it's going to be a small number, so we don't have to worry about all this weird stuff that I'm doing. Let's just kind of wing it. I think I know how to write this kind of code by now. So let's wing it and see what we come up with. So here we are, Snorky guy. So what we need to do is pull accumulator, and this is going to be the direction 0 through 3, or yeah, 0 or 1 for now. Left or right, and we'll say 0 equals left and 1 equals right. So we remember that part. So now we have that value. What do we do with it? We need to we can multiply it by 13 and add that in. I think I may store it in pdir just so we have it for later. And now we'll multiply it by 13 and add it to the pguy address. So we're going to need to actually now multiply by 13. We'll be multiplying by L versus R. So one thing we can do is just, let's see, well, first we need to multiply we'll get the frame number as well. That's one of the, I guess, the other things we're going to need. Frame. So there we go. Direction, I think I'll lowercase these things. Can't make everything uppercase. Direction, frame, and XY. So which direction and which frame? Or we could just have frame and figure that all out in the code, but for now we'll do them separately. since the multiplication will be cheaper here than it would be in basic with the floating points numbers. So here we go. Direction left and right. We've got very good. So with this one, it's fairly easy. You just say BEQ, no add, and then no add. And we'll do a little add here. I guess I'll have to do a clear carry for now. Unless I can be guaranteed that it is cleared. This add with carry should clear it. Therefore, it should be clear at this point. So add with carry number R sprites minus L sprites. So we should actually do this. Load accumulator first, and then add with carry. To P guy. And then well, I can actually have a macro for this. Let me see. It's called add to pointer carry known to be clear. P guy. So that takes care of that. The only reason I don't do it up here is because I've already got the thing in the accumulator. So now we've gotten that sorted. So now we've got to get the actual frame number and multiply that by 13. That's the one we multiply by 13. So let's do that now. And that'll be 0 through 2. And we need to multiply it by 13 and then add it into the address. So in order to multiply by 13, we do, let's see, I guess I'll use, not using PDIR, I'll just call it PTMP. You can use any old temporary register or whatever, but we don't have a lot to work with. And there's no like add X to A or add A to Y or anything like that, which would be nice. Those would be very useful. So okay, so we added that. Now we've got the okay, pulling accumulator frame 0 through 2. Now we're going to be taking that and multiplying it by 13. So we could add it once. Or, we could just do the adding like this way. Like if we know the carry, again, if we know the carry is clear, which we typically do, the high bytes aren't going to be overflowing on these. We can trust that. We'll trust it. We need these to be small and not check everything. So first thing we do is add it, and now we do an arithmetic shift left on the accumulator, which multiplies it by 2. So we need to multiply it by 2 twice, and then add it again, and then multiply it by 2. So it's been multiplied by 2, 4, and then 8. So 4 and 8 makes it 12. And then we add it again. So that's one way to do it, but we don't need to keep doing that. What we really need to do is, we know it's going to be a pretty small number, so we can just, we need to store it in ptemp. So what we really want to do is sta ptemp ASL add with carry ptemp, or I should say sta ptemp ASL add with carry and then basically add with carry ptemp. We don't have to, now we don't have to store it. We can just use that as our value to add here. So this is times 4 times 13. Let's see, is that right? There we go. Plus 4 equals times 5 and plus, yeah. I think that works. Just trying to see if there's a, like, any way I can rearrange things and not have to do the store, load, add, blah, blah, blah. But I think it all works. We're good. So that's good, and that adds to our pointer, and then now we've got it multiplied by 13. Good. Now I'm just going to double check and make sure these are 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep, 13. Okay. Triple checking. I did set that. I remember doing it. All right, so now we have a pointer to our source address. So we're all good with that. Now what can we do? Well, I mean, I could even put that into a register and use it as the index for fetching, or something along those lines. But now what we need to do is get the player address and the XY, which is like, we've done that before. So, and we don't need the size. We know what the size is. So that's going there. I don't know if we need to do it here. Number 13. So let's see, what's this? X, Y, we don't need the old Y. Oop, goodbye old Y. So we could call p guy p source, which I think will match up with some of the other stuff that we have here. We don't use p top, so that's fine. Do we? No, we don't. But we will be in a moment. So let's get p top. That's the next piece to do. I did need to do that part, but it comes later. And now is later. Boom. So here we are. Get player top. Then we'll get the Y. Boop. Okay. And then we need to add Y to it sooner or later. X is actually pretty easy. We store X in there. Oh, I forgot we're going to do some subtracting on Y as well. Don't let me forget that part. So here we go. Get the player top. Get the X coordinate and store it. Subtracting 4, correct? Yes. That's going to be how we're centering on this stuff. And then the Y is going to be, I think we're going to be subtracting something like 11. We'll say maybe we'll just subtract 13 and make the feet. We'll say subtract 12. Take a middle ground. Okay, so move player Y. Okay, and now Y, new Y. Okay, so now the Y is going to be, the cool thing about Y is we just add it to ptop and we're done because it's that simple. Whole new Y, add with carry, p top. And then store p top, I guess. The other thing is we can also like use again, just use it as the index as we draw, but we'll see what happens. So the next part is now we know where we're drawing from. Now we know where we're drawing to. As far as the old Y goes, the erasing of the old sprite in its old position. This is where it gets a little tricky. I think I'll go with old, just say OY on this. Old Y, or whatever. So that we can erase it in its old position, and I'll do the tracking in BASIC for the moment because I just don't have a special place to store it right now. So, well, actually, you know, I can actually use. I'm being a little silly. At least as far as like, if I don't mind not using non-zero page, I can store anything inside of this because this is going to be running in RAM for the moment, not in ROM. So I can actually write into this if I want to. So let's do that. Let's reserve 2 bytes here. See if that works for us. And we'll call this we'll be keeping track of the old Y. Old Y. And we'll be keeping track of, we could just make it a byte, I suppose. We'll make it 0. Or, yeah, something like that. 0 would be too high. We could just make it 13. Or better yet, we'll just stick it somewhere in the middle. We're going to be clearing the bytes, 13 bytes at this address, and then redrawing them, just because it'll be faster and simpler than doing magic stuff to copy and only erase the parts that change or whatever. So then we have old Y, and then we'll have, I don't know if I need anything else, honestly. Maybe old Y is all I need. So we'll go with that. Okay, so now we've got that drawn. We're adding to ptop and storing it. And we'll just call this pdest now. pdst. There we go. And we'll see what we got as far as where it's used. New Y. Clear carry, add it, store it. Very nice. Subtract carry, store, accumulator. Yeah, so we do need to clear the carry here. And then as far as the old Y goes, we don't need to pass it anymore. We'll just assume we have it already. And we'll just keep track of it ourselves. And it's only going to be 1 byte. Yeah. Cool. So what to do? Well, let's do the thing where we erase and draw, I guess. And in this case, we don't have to worry about which way we draw. So we can loop down, we can loop up, whatever. So for now, we're going to loop down in every case, I guess. And as far as this comparison goes, don't care. And then as far as that goes, I think I did that already. Okay, and then we're loading Y number 13. Cool. Cool, so now we have, there we go. Yep, address. There we go. Pretty simple. Don't have to do much there. You could just put Y there and loop upward, I suppose. Counting X down instead. Like I could do this. Load X number 13. load y, number, whatever, tax, tay, right? Then loop, load source, store, destination. What do I have in X? And why do I care? Let's see. Oh, right. Don't care. DX, but also in Y. And don't need that BMI exit thing. So I think we're good. And then the only other thing to do is to store the new, do the clearing, and so we'll do this. Copy, oops, copy. We'll do the clear first, I guess. At the old Y, since we could do it anywhere up here, and frankly. So let me make sure I got this straight. Source, transfer Y to the accumulator, add 0, store it, etc. Let's see, is there anything else I need to do? Get the direction, multiply by whatever. Okay, do the multiplication here. Should make that part of that. Here we have multiply by 13. Add to source. Get player top. Boom. Get X and set position. This stuff would tend to be done in, again, vertical blank. All this stuff should really be done in vertical blank and just triggered with a flag or something. Set carry, subtract number 4. Once we get it working that way, you'll see the difference between the kind of jaggedy animation and the more fluid animation that you get. And then we have destination, player missile address, get Y, and final destination address. Cool. Add to destination. And then, so if this is, I don't necessarily need to add it. I can just transfer it to Y. We know the destination, again, is going to be between 0 and 255, so we don't have to really worry about it. The only trick is we have to make sure that it doesn't underflow. So, yeah, that's one trick, though. So, see if I got this straight. Y for the final destination. Oh, wait, we have to kind of have it be 0 and stuff, so yeah, I got to do this. Oops. So we could do it this way. DEY and BPL. So as long as it's, you'll still do 0 in that case. So now we do the, draw the sprite. Draw the guy. We need to do the erase part. So we're going to need to use the old address. We're going to need that, so I'm going to need 2 copies of this, apparently. Or I can do a thing where I subtract that value. Nah. Let's do it this way, where we keep the old low value. And it looks like we could store it in PTMP because we stopped using it. We need 2 copies because we're going to be restoring it. So first thing we do is, before we get Y on the final destination address, let's clear the old one. So load accumulator old Y, please. And now clear 13 bytes at that location. Add with carry. Let's see, I could do something where I do load X number 12 or whatever. Load Y. The accumulator needs to be 0. I need to clear some stuff. So old Y. Load accumulator number 0. Erase the old one. And we'll do it this way. We'll say STA the DST. It looks like I don't need to modify it, comma Y. In Y. DEX DPL clear. And clear is here. Clear is here. So that it does the job. Let's take a look. We erase the old sprite by loading a 0 and X with 12 and loading Y with old Y and storing the accumulator in that destination address. We increment Y so that we clear up to and including a certain number. The only other thing I need to do is stick a thing here and say for clear done in the case where good overflows. We don't want that to happen. Like if it goes too low for some reason. This probably wouldn't happen, but it's the kind of thing that should be there just in case, so it's a failsafe. Keep it there as a marker to remind myself. But in general, it's like if you just avoid doing the wrong thing, the worst thing that'll happen is it'll come into the next sprite. And the only other thing is old Y should never go below 0. So we have to be careful about that as well. Anyway, overall, fun. Moving on. Because of the way I'm working with this, it'll like wrap around with Y and stuff. So we'll get some interesting results. So in this case, we're doing a thing where we are copying the data. So there, draw the guy. I think we did everything now, so it's all good. We got to add this to the build at this point. So let's see, this is not going to be something I think we'll be able to just have as a routine considering it has all these bytes in it. I'll have to put these bytes somewhere else. Maybe in BASIC, I don't know, somewhere else. We'll see. Maybe I can make each one into its own separate file. A little annoying because I just want to done and make the data go. But this is not going to fit. I can tell already. So anyway, init move cube. So instead of move, let's add a copy of the Snorky sprite code. And we'll make it Snorky sprite. Guy. We'll see how this works. So everything where it says move, I change it to guy here in this section. Guy. There we go. All the guys. And now I have to add that to the list of things to build. When we build all guy. And view move, view cube, view guy, and probably view init are all things that don't create files of their own. The only thing I won't do yet is, I don't know if I can't really throw it in here yet. Well, I could. You'll see how huge it is though, that's the problem. Let's call this guy bin. Guy bin here. A guy bin, just to keep it simple. I don't know, guy bin, whatever. All right, guy. So I just wanted it to all line up. I'm anal that way. Let's see. Okay, next we got. So now if I do make, it should try to build it, and we'll see what we get. I'm sure it'll be a mess. Here we go. Moving on. Clean. Make test list. And oops, wrong place. Where's the proper folder? That's not it. That's not it. That it? Nope. That's not it. That's not it. That's not it. Sorry. Very basic. Me. All right. All right, we're there. Make clean. Make test list. There we go. Did get built. So I don't know what that means. It just means that it built. So I need to look at more code at once so I can tell if it looks right. We were looking at it really close up there. So let's back off a bit here for a minute. So we never did any of the reservation stuff. I did use this for something. And never needed to store that, so we can throw that away. And, you know, rebuild it, why not? We can look at the list and see exactly how long that line is. I bet it's very long. And, oops, I forgot to call it something like this guy. But, oh, it's not as long as cube. So, cool. That's actually, I'm surprised because I thought the data would make it really long. The data itself is only 100 bytes or so. So as long as the code itself is simple, which it definitely is, just clearing and copying couldn't be simpler. The only hard part is pulling all these bloody arguments down and doing the adds and stuff. It's such a hassle to add. Adding is boring. Multiplying is so boring. And I don't see any good way to make it like simplified, you know. ASL, TXA there? Would that work? No. Add, and then, yeah, so I don't see any way to do it besides using temporary registers and zero page. So yeah, player top, address. Erase the old sprite. Very cool. I thought I would need to worry about saving and restoring things, but I didn't need to. But I did need to make the destination, did need to update that. So the only things that I'm updating in the destination is, yeah, it's just adding that small number. Yeah, so okay, I'm feeling good about this. Load Y number 12, copy backwards, or in this case we're just doing copy. We know how to do that. We don't need to necessarily label it. And exit is there. And we didn't need it, evidently. Old Y is we just keep it for later. Okay, well now let's make a little test for this. I guess what I'll do is kind of just have it randomly move around or something. I'm not sure, but let's take a look at what my listing looks like. S guy. Hey S guy, what up? So let's call this okay, now I'm gonna do one very quick test of it and just see if I mean I could make it the second player so that I can test both. So let's at least do that for this hpause p0 and so on. Right. Let's do that for now. Some of this stuff is pretty straightforward to do when they're 256 bytes tall, if I do need to specify the sprite number and so on, which I'll be doing later with this stuff. And instead of Snorky Guy, I'll have a bunch of different things and we'll be passing the data separately. And I probably will have it in just like some little pile or table. I don't know what will happen. But we'll see. It's pretty fun to build these things out and see what happens. You can see I'm kind of making maybe making a somewhat overcomplicated bunch of stuff here, but you know, this is so I can do repeatability and come back in the morning and just run it and so say, oh yeah, that's how that works. Here's the code that demos it, and so on. So be what it will, it works. Moving on, we've got S guy. So let's test S guy now. So 40, and let's make that 60 and make 50 our test for S guy. So let's just do P1 equals P0 plus 256. Oops, P0 please. Cool. There you go, 256. Good number to have. So now, got my P1, I got my P0, I got my PM base, and I got my S guy. I don't know, I guess the only other thing to do is poke the other color for the next player, 705, and add, I don't know, 64 to this. So 168, I don't know, just add some arbitrary number. And now we'll do equals USR. This guy, S guy again. What was the direction? So we'll say, I don't know, N0 for now. Frame number, N0, and X and Y. So for X, we'll say 100, and for Y, we'll say, I don't know, 128 in the mid, sort of in the middle. So let's just go with 128 for now. And rather than 100, I'll go with like something smaller. I know 48 is the left side, so we'll go with 64 or 70. Make a nice even number. And make this one 30. So another nice even number. Oh, actually, the old position was 128, so this may help in that regard. So I think that's all we need to do, and it will work. Let's go. Oh, it reset. It didn't like anything about what I did. I could look at the debugger maybe and see what crashed, possibly. There's a way to do that, but I don't remember how. Let's check our code and just see if it's anything obvious jumps out. First of all, does it take the right number of arguments? 1, 2, 3, 4, 5 plus the original. Let's count them. 1, and we don't care about it, so we're throwing it away. 2, so that's, wait, 1 is the address of the USR itself. 2 is direction, frame, sprite address. Oh, I forgot to pass P0. That's kind of important. P1 in this case. All right, kind of more important. The cool thing is you can crash this thing all day and it won't crash the anything else. Oh, what happened? Did I get it right or did I miss it? Is P1 supposed to be the third thing? Because source destination. I think that's the idea. So hold on. Bring it over. Oh, it crashed. Damn. Check our code again. So again, we're pulling. Right. So we got that. Now we got pull. And frame. Okay, multiply by 13. So we did get the direction, then we got the frame, now we get the player address. Pull accumulator. Gotta make sure I'm not doing that way too much. Store and destination, load accumulator, load X, load Y, old Y. So we're doing the clear, storing. And then, I did the increment of X correctly? 12 BPL. Oh, it looks like I don't need to worry about I'm not using it for anything, so I can carry on with that. 13 bytes, load Y with old Y, increment Y, decrement X, it is clear, blah, blah, blah. Load accumulator number 0, store it. So I think that's good. And now when its clearing is done, now we get X and also set the position of the sprite. We could even do that earlier if we wanted. Like we could do it here before we do the clearing. In fact, this kind of stands alone, so we could even, we don't want to do this yet. We don't want to modify the destination address. We just want to leave it where it was originally. And then later we can modify it. Again, we could also do the same trick using Y if we wanted to. Load Y with PDST or whatever, or load Y with oh wait, PDST also, yeah. The other thing is we have to make sure that it isn't modified. So at least here it's fine because we want it to be modified. Here we don't. So let me think about that for a second. Add. So PDES should just be 0 actually at this point. So actually that's the cool thing is we can just store it. We don't need to add anything there. So now when we load Y with 12, we're all good. Destination Y, DEY, BPL, copy because we do want 0. And here we do want 0 as well. We want old Y up to whatever it happens to be. So I think we're good, but I don't see anything else where I need to like, there's an RTS. Oh, I forgot to store in the old Y. That's one of the things I forgot to do. Once I get Y, I should store it in old Y. So let's get that. So here's Y, store in old Y. There you go. And okay, let's do another build, see what we get. It'd probably still crash. But we gotta know. Oops, let me get that code back here. So it's gonna crash, but that's fine. Oh, and I forgot P1 equals P0 plus 56. All right. We don't really care about performance here, so let's just do this thing. Watch it crash. Okay, it crashed, as I expected. Is there a way to enter the monitor? Yes. Unfortunately, when you do it, it doesn't like where I'm entering it from, so it crashes. And then I have to force quit it, so hold on a sec. While I do that. There we go. So yeah, it gives me a bunch of crap when I do that. So, oh well. All right, well, in any case, let's take a look and see if there's any obvious bug. So again, pulling that, putting that in Y. Pulling, so we got two pulled, correct. Clearing carry, adding data, or source data. We don't have to worry too much about source being wrong. We transfer Y to the accumulator, we add 0, and we store that. Okay, so now let's see if that's correct. TAY. I think that's wrong actually. Let's do it this way for now. No ink. So that's important. There, I think that's better. Let's see if that makes any difference. I need to make sure I preserve my test list code here. So let's get that into the make file. v1 equals 256. Line 60 is return. Line 50 is this. All right. Anything else I need to think about or care about at this point? Maybe not. There is an old Y for some other things, other purposes. Do I even use it in this anymore? I do. I use it for something. Oh, and I see OY. Yeah, okay, that's fine. Anyway, moving on. Let's watch it crash. Oh, it crashed all right. Never mind. You can see it crashed. So if I don't want it to, I have to get the command that I use to run it. Like I would say, grab my running command here in a moment. Helper. Run Atari Basic run. And get my final command here. Putting things around things to debug things. This is kind of useful to keep around, so I may keep it around. So if I do the build of this now, I should get the command line I used to run it. Did I? No. I have to open up the correct one to get that. And I don't think I have that open at the moment. Let's see, where are you? Where are you? Yeah, so I'm going to get going soon. I just wanted to sort of run through this process of making this little guy, but it's like a bit of a hassle, isn't it? As you can see, it's a bit of a hassle to get all these things built out. But once they are, and once all this assembly code is in kind of together in one big happy family, it'll be pretty cool. Let's see, did I get the right one? I think I did. That's supposed to be the one that's in C2. Let's see. Oh, wait. Nope, nope, it's not. What happened to that? I could have swore. I had it. Components. Auto build. Comfy sap. 6502 tools once, going twice. Yeah, what do you know? There's only that one. Well, okay, that's fine. I just don't like navigating around when I don't have to. Application support, Sublime. Text 3, packages, user, Atari tools. Here is the one I wanted. Okay. Where were we? I really should just have those things be links, shouldn't I, at this point? All right, so there's the command that I would be using to run it. Now, if I run it from the terminal, I'll be able to use the debugger. That's why I'm doing it that way. So we let it crash, and then we enter the monitor. And check it out. Where are we? I don't know. Somewhere. I don't remember what commands to use. D for disassemble or something like that. Okay, I gotta figure out what address I'm at and all that kind of thing. I don't know. PC, I guess. PC says 0016. Somehow I ended up there. I have no idea what's going on. Maybe I left something on the stack I shouldn't have and it tried to return there. That could be what's going on. So pretty cool. How do I get out? I guess Control C. I'm not sure. Or just say Q or X or exit. Exit makes it go away. That's cool. Okay, so yeah, what's going on with this? I don't know. I think maybe I'm not cleaning enough stuff off the stack. I'm not sure. So let's go back to Snorky Guy and take one last quick look at it and see if it's good. So you get the source address of one, and we get the other one. We're going to point at our graphics data. We get sprites minus the top of this. We get store in there. So we're adding, and then we increment this if that overflowed for any reason. Otherwise, we continue and get the direction, 2 bytes. If it's equal to 0, then we move on. Otherwise, we assume we're going to be pointing to the right, which is that amount there, 39, something like that. We're going to be adding 39 to that, and then the next thing it does is, I think it's cleared. Next thing, we get our temp address, which is, oh yeah, the reason we're using temp is so we can multiply by 13. So we get this, we store up times 1, then we multiply and we add, and now we've got the value times 5. Oh, I did something wrong. Okay, that's the problem. Hold on. I need to transfer this to like any old register. We'll say X. Add store, but then I have to get it back TXA before I take that and make that times 13. Add, yeah. So I don't know, is there a neater way to do this? I'm not sure. We could throw it in like, let's ask LM Studio. Let's see if it can help with this kind of thing. Is this the only way to multiply by 13 in 6502 assembly language? Let's say most direct. Emulator. Right, times 2 times 4, making it times 5. Then you add it to that, and then all right, let's see what it says. GPT-OSS is a small model, so it may not know much about this kind of thing. Oops, I meant to say 6502. No, it's a perfectly legal way to multiply, but is not the most compact or direct one that a 6502 programmer could write. 8 times 2 plus x So you only need 3 left shifts and 2 additions. Yeah. So what? X times 2 times 4. Then you put that in X, and then you add times that to get times 5. Right? And then times 10. Why would we want that? What are you doing there? 23. This makes no sense. It's just riffing. Then here's one where it does 2, 4, 5. Wait, now 10? We don't want to do that. So yeah, I think it's choking. Temp ASL is times 4, then times 5, then no, it's times 11 at that point. What are you doing? I don't know. There may be some way to do it, like times 5 plus times 8 is times 13. So that's kind of what I went for. And you can see it's, I don't know. Right? You gotta have that times 5 and that times 4 so that we can get the times 8 again. I suppose you could do something like where you do add the times 8 and then go back to 4 and then am I making any sense? I don't know. I'm just thinking out loud here. If you go times 8, then go back to 4 and then like what if I took times 1 times 12 and that added times 1 to it instead and just went through all this other stuff? Like add the times 1 at the end or something like that. Let's try something like that. Let's do where I do it at the end. Save, and then we get times 4 again. Times 8 is times 13. So um draw. So times 8 times 13. I don't know. Let's do the trick with times 1 and then times 12. So we'll do it this way. We say, boop, set some room here. Times 1 and transfer that to x. Times 1 save. Times 2 times 4 times 8. Oh wait. Times 8 and then add that ptemp and then txa. Can't really do that. I need to add x to it. tricky. Times 8 times 4 times 12. And then if I said something like, TXA and then BEQ or whatever, and then ink, that kind of thing. BEQ, no ink, or whatever. Is it though? It isn't. You can't just increment, you have to add. Darn it. So I don't know, it kind of adds up to the same thing. You could do like a times 16 and then subtract times 3. No, don't do it. So yeah, times 1 is saved. Times 4, times 8, times 12. Yep. Yeah, so I don't know. Times 1 and then times 5 and then times 8 kind of all amounts to the same thing. How many instructions do I have here? 1, 2, 3, 4, well, count bytes. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 bytes versus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 bytes. Oh, the same. Exactly the same. So yeah, whether you save times 1 or times whatever, it doesn't seem to matter. It'd be cool if I had times 10 and then I could add times 3, but I don't have that luxury. So I don't know which one I like best. What do you think? ASL times 8 plus times 13. Putting times 4 in X temporarily instead of the times 1 temporarily. I don't know, it kind of doesn't really amount to much. It's sort of the same thing. Either way, it's still crashing, so we haven't figured that out. The last thing we got to do, and then I'm going to take off, get some rest. But yeah, this has been fun. Let's see, we got pull accumulator store in their destination is the next part. So we did the 2 pulls there. We did all the things we needed to do to multiply it by 13. We got the player top address. Then we subtracted 4. Oh, I forgot to do a thing where I subtract from y. We got to pick a number to subtract from y. And I guess the old Y we can use, we can keep it intact as being whatever we stored. I don't know, does that make sense? So there's 12, and we decrement Y. We've updated the destination. So, and we've also stored an old Y. So let's do it this way. We'll subtract, how about 12? We'll store it in both the destination and the old Y, because the drawing that we do is from that, assumes that's the top. There's no subtracting going on for the erasure. And so it'll have the same value that the drawing had, basically, that we used. Gotta remember to subtract, set the carry when subtracting. Okay, I think we're good. Let's build it and run it one more time. Oh boy. And let's see what we got. Let's watch it crash. Let's watch it crash. Oh yeah. I need to be able to catch the crash in the monitor somehow. I don't know how. It's at address 0016 again. So I don't know how it's ending up there. Let me think about that address. That's the number 22. That's none of the values that we're passing are 22, are they? Where it could be pulling that off the stack and forgetting that it's there. Doesn't look like it unless it's this one. 130, 70, no. So, what's going on? How long is this routine anyway now? Oh, it's getting there, but still not too huge. So what do you suppose is going on with it? Should we try P0 just to see if that has any effect? Doesn't. I can tell you it doesn't. I wish that thing opened up on this screen where you can see it. It would be nice, but for some reason it doesn't. Let's see, it always opens up on the main screen, I think, which is my middle one. So let's go with, what do you suppose? I don't know. It's a mystery at this point. Subtract 4 from OX. I gotta make sure X isn't too large. Store that in HPOS P1. Maybe I could try 0 and make sure that works. I don't know. You know, I get the same thing either way, I think. P0. Yeah, it crashes again. I don't know, this is tricky. This is very tricky stuff. So I don't see that that would cause any issues. P destination +1, then P destination. Again, I'm really checking carefully to make sure I'm not pulling too many things off the stack. And then the last thing is the Y destination. Stores it in both the destination and the old Y. Then it does this where it loads Y from old Y. I could do that ahead of time. And I could do this up here before it does the erasing. That might be a good idea just to sort things out a little bit. Load Y from old Y. Let's do that up here before we do this. I want to get it before I change it. That way I don't have to worry about changing it later. As well. Or whatever, it's already being changed later, but just get all these arguments before I actually do the actual final action of erasing the old sprite. Which I guess, it doesn't matter which order I do it in, but I don't know, what do you think? Was it better than before? I don't know. I don't know. It's fine either way. Store in old Y, load Y from old Y, whatever order you do it in. So yeah, so it's doing this where it's storing the destination of where old Y was before we modify. Yeah, we want to definitely not modify destination. That was why I did it this way. So destination has not been at all modified yet. We get the old Y, we increment it a certain number of times, we decrement X by 13. We know old Y starts out being 128. Oh, wait a moment. Wait a moment. That's not going to work either. We need old Y to be some page 0 address that isn't going to be touched by other things. So yeah, it actually works out that we can't use that. Not that way anyway. We have to do a thing where we use the player address, the sprite address in some way and point at that. So we could do it this way where we say old Y equals, here, and then we use something like old Y equals, let's see, sprites minus, so the source address basically. I don't know. I don't know if I want to do it this way. Let's just find some page 0 address I can use. Something that's safe to use. Let's go to, sorry, I'm going to blow your eyes out with opening up this thing. Yes, it's the memory map. So yeah, there's not a lot that BASIC uses, but there is actually. But if you're not using like the disk, for example, I could just use like some of these things. Like I don't care about no checksum follows data. Let's use this address, 60. Why not, right? Or how about the cassette buffer pointer? We don't care about this. 61. Let's use 61. Why not? Which is 3D. Yeah, we'll do it that way, I guess. I'm not using cassettes, so. Cassette? Is that how we spell it? I can never remember. It's been so long since I've used one. Alright, moving on. Cassette tape, baby. So old Y, we don't need that anymore. We can throw it out, but also I should probably, it's just going to be some arbitrary number between 0 and 255, so I kind of have to watch out for what it equals. So I do have to do something like when it goes over 0, make sure it doesn't overflow. Or in some ways it doesn't really matter because it just wraps around within the sprite, so I could just leave it alone and it should be just fine. So good, old Y. is sorted now. Maybe it's sorted. We'll see. Oops, can't just run this yet. I have to build it. Okay, test list. What's going on? Still crashing on me? Yep, you sure are. So I don't know. This is really confusing now. P1. Did I tell it to still use pause P1? So I don't know. It's still crashing. That's strange. Get the wide address for the destination. Subtract 12 and store it here. Store it in the old Y. Right. Cool. Equals 3D. Here we get the old Y. Yeah. So the last thing we get is Y. And I assume that's all the arguments. Yourself. The direction, the frame, the player, the X, and the Y. Maybe the direction and frame aren't properly. I don't know. Take a look at direction and frame one more time. Right. My own address twice. My direction twice. Two poles. PLAs. My frame. My player top address. My X and set position. My X position rather. My old sprite being erased. Store PDST, Y. Oh, actually, you know, it does matter if it overflows in this case, in some cases, because of PDST being. Well, no, it doesn't actually. Again, PDST hasn't been modified here yet. But now we're taking Y and we are modifying PDST. And we're storing both. Okay. Now we load Y with 12. We get the source and the destination from those indexes. We decrement Y, and while it's plus, we branch. And otherwise, we return. I don't know. I'm lost. So anyway, now I got to do something like enable the debugger. I think there's a way to just do that from the config file. Let me see. Let me go to my thing here and do I don't know if I need to enable it explicitly or if it just automatically gives me the thing, but I'm kind of confused as to how it ends up at that address. And that's, you know, hard to figure out without having some kind of breakpoint situation, you know, where it shows you where it crashed or whatever. Just ends up trying to jump to address 16, and I just don't know why. There could be other things going on, I just don't know. There is an RTS here. All the other stuff seems totally in order. Load from source, store, and destination. Decrement Y. Is destination being messed with? Is source being messed with? Just don't see it. High byte, low byte. Store low byte. Increment high byte if necessary. We don't know if the carry is clear here, so it shouldn't make much difference. It's like 1 byte. Then we have no ad. Right. Okay. Mm-hmm. Don't see it. What am I missing? What am I missing? Load accumulator, load X, load Y, store. What's going on here? Increment Y, decrement X, B and E. Clear. When decrementing X. X is 13, which should be fine. Hold Y again. Hmm. Hmm. I don't know. Debugging this kind of stuff is tricky. I'm gonna have to figure out some good techniques for that. At the moment, it's kind of not, I just don't really know where to begin. All I know is it's crashing, and when I enter the monitor, it gives me nothing useful. Once again, let's go to the tapes and see what we got here. So we load it up, we let it crash, and it tells us it wants to go to address 22. I don't know exactly what to do except maybe warm boot, warm start. Now it wants to go to address 0052. Oops. So the code is still there. So how do I make a breakpoint somewhere and make it work that way I want it to? I guess I could figure out what the address of the string is and look at it. So, and maybe run there. So let's do that. Oh, I actually have to run the code to do that. Let's do this. I'll do this quickly because I'm definitely fading. All right, so the keyboard joystick does seem to be off. So let's do this. We'll turn that into a comment. If I put a dot there, you'd think it would make it a comment, but it won't. This 50 period is a legal number. So what I really want to do is just make this into, let's just do this, 42 return. Hey, now we can run this. Oh, it's still resetting. Why? Now you're confusing me, because it's supposed to not be doing anything. Not supposed to run that at all. It must be running something else that's killing it? What the hell? What's going on? Maybe there's an old bug that I didn't notice before that's just being triggered now. Let me just do a quick, we'll quit that. We'll take out this. We'll take out this. We'll just run it like it's old school. See if it's, no, it's not crashing when I run it old school. So when I reintroduce this and then put this in as a comment, and we'll run it again. Oh, it does reset. What is going on? Just from having this line in here, it's resetting. That's confusing me. You're confusing me. So if I make it into a comment, it just, Oh, it is resetting again. Okay, now you're confusing me even more. Maybe it has to do with the size of this, like because I'm using peak 106 and doing tricks like this, it doesn't like that. What about P1 being P0 plus 256? Does it not like that? I'm very confused, sorry. It's resetting again, it's crashing. What? What? Now I'm very confused. Did I mess something up in the running? No. Don't think I did. I don't think I did. Wow, very strange. I don't know what to make of it. Huh. I'm genuinely perplexed. Well, at least I know it's not just me and my code. My code's probably fine. What if I run my Snorky by itself? Okay. What if I put that code in there for some reason? Like just put this in here. Okay, and then run that. It crash on me? Nope, didn't crash. Um, so that's kind of cool. So maybe I can do a quick test in here in my test LST. Oh, he's still gonna crash. I don't know. We'll see. Oops. It ended up overwriting it. Hold on. Let's make this, I don't know, 999. Okay, hold on. Looking. Okay, now you can see it's running fine. So, yeah, what's going, no, not this part though. We'll get there. Give me a sec. So what do we need? We got 12,001, 13,000, 12,000. Right. Okay, so let's put this in here. Cool. And then as far as the moving of the guy, that happens at line 12,000. So let's actually run that code. And we'll see that that all runs. Okay, it does run. Although it's not doing the animation now, probably because, oh, it's not supposed to. But now I want to draw the little guy. So instead of drawing the move, let's do our own version, 16. PR equals USR guy. S guy, P0. Right, we'll just do frame and direction 0. And then we'll do PXPY, I guess, and see what happens. Hold your breath. It's going to crash. Nope, it's not crashing. But it's also not drawing what I expected either. Well, it's not drawing at all, is what's happening. So, but let me do the joystick thing and see if it's doing that. Oh, oh, oh my God. Okay, guys, check it out. All right, there's our dude. Happening, it's happening. So, yeah. Very good. All right. I don't know why it was crashing all that time. Sorry about all that noise. But we are back in business. I just need to put the right sprite in place and all that. Let's make it position 0 or whatever. Oh, I could even do 1, I suppose. Let's just go back to test LST and or Snorky LST and put P1 here instead of P0. And P1 equals P0 plus N256. What about P0x? Yep, we do stuff like that. And PBX, what is that? Oh, that's the leftmost part of the screen is PBX. Okay, according to the current display setup. Boom, building. And gotta turn on the joystick again. Sorry, I had it off because I'm like, sometimes I really do want it just to be bloody well off. Oh, look at that. Little dude moving around. Colored badly. I gotta change his color. Where's 704? 705. Let's make this, I don't know, add 80 to this, 168. And I wanted to make him bright green, I guess. I don't know. How about 234? Does that do the trick? We'll see. Joystick. Oops. There we go. There's our guy. All right, so we got some things happening. Drawing is occurring. I think my guy, as I remember, like I seem to remember the sprite being much smaller when I originally created it. I don't know why it has this. It has a double line looking resolution, doesn't it? But it is a single line resolution, as far as I know. I just don't remember it being this chunky. But yeah, there you go. So there's a little guy. He can move around in space, but we're getting there. So yeah, how about that, huh? So that wasn't too hard. Just a lot of that chasing things that were phantoms. Now we got past that. It's looking pretty good. Okay, so we'll come back to this little fun game project soon. At least I found a pretty decent online tool for drawing sprites. Maybe there's better ones. I guess I should save this and we'll call this norky1.spr. Yes, I do want to allow downloads. So there, this will be fun to explore, playing with the different frames and getting into like trying to make animation, which is one of the trickier things. Like on the Atari, it's like, especially working from BASIC, it's like, yeah, you can make a little table of things and have it run through them in a loop. But what we're going to want to do is get good synchronization with the screen, and we're going to want to get animation that is, somewhat modern and clean and good looking. We don't have a lot of pixels and colors to work with, so we have to be very creative and suggestive and surreal, I guess, sometimes. But that's fun. Be abstract, get crazy, make things a lot more like iconic, which is, can make a big difference in the experience that the player has. Of course, we also have the ability to use pixels, so I may explore going beyond this and drawing with 3 colors and seeing if I can make something decent with 3 colors. Problem is that with this particular graphics mode, which is, I'm kind of going to the lowest common denominator because that's what I had back in the day when I first built this game. I only had these 3 colors, so, and these few sprites, so you had to work with what you had. So to make it interesting, you have to do things like split up the sprites vertically, or and reuse them and do other tricks. And to multiplex them gets a little tricky if you're letting them move vertically into different layers. So you have to kind of be very clever in how you combine your sprites and avoid. Uh, Basically, I also want to like avoid having sprites that flicker. So one of the things you can do is you can do things like wait a certain number of cycles across the screen on every line and move the sprite to the newer location after it's been drawn or whatever on a particular line. And you can have little multiplexers that kind of follow it around, and yeah, it gets really crazy what you can do as far as chasing cycles. But nobody wants to be counting cycles on the screen if you can avoid it. If you can just synchronize things with the vertical blank, you're best off. You get, I think, 60 frames of vertical blank, but effectively, I think the real display was 30 frames per second because it was interleaved. But someone can correct me on that. I think your original TVs were interleaved, so the 60 FPS was kind of like, yeah, you get it, but if you do, you get some tearing or like weird factors. You wouldn't notice them on most TVs back in the day, but as they got better, it became more problematic. So we're good to have the displays we have now. We're lucky. So this is pretty cool. We ended up with only needing a source, a destination, and a temporary variable, a little place to store the Y, which I ended up storing it in the cassette location that's not being used. So, and the data was easy to generate. Got it out of our little sprite editor, and yeah, so we're good to retro on to the next level. So thanks for joining, and I'll see you next time. Tomorrow, another full day of Marlin, I guess. And I don't know, maybe I'll go fishing on Sunday or something, get a break. So anyway, check the links in the description on this video for links to this project and other ways you can support my work. Want to keep this thing going and make retro new again. The Commodore 64 was happening just recently, a new revival, and I'm sure we'll see a revival of the Atari 800 platform real soon too. So, and 5200 and 7800 and that kind of stuff, because there's a lot of really cool stuff on them. It's definitely more sophisticated than what I'm making. So I think it'll be cool to follow along with that and show you guys how to actually do some of this stuff, because it's pretty fun once you get the hang of it. It's just this annoyance of like getting used to the fact that, oh yeah, you can only use comma y like this and you can't put an x there. That's illegal. That's not a thing. So you just have to use y. You have to get used to what registers you have available, only a few. And this stuff is annoying. Multiplying by 13 is annoying. All this stuff is annoying. But at the same time, it's fun little challenges that once you've solved them, you don't have to go back and do them again. You've got a facility you can come back to again and again, reuse in your games, reuse in your Atari Basic prototypes and whatever else you're doing. Some of this stuff, I'm sure, is already out there as real little routines that you can use and just download from magazines or whatever. I'm sure there's like discs of like all the routines that you would use to draw sprites in Atari Basic, all the routines you would use to do fast random access disk IO in Atari Basic. All that stuff is probably out there. I used some of that stuff when I was writing my disk editor back in the day, the tracer, which you can find on archive.org. And back when I was writing my Epson MX80 or something, I think it was the printer I liked, but I managed to get that to print Atari fonts using writing a driver. And writing a driver was surprisingly not too hard. Just had to get the bits that were the text that was being sent, figure out what and then set up the graphic mode on the printer, and then take the bitmaps of the current fonts and turn them sideways and stretch them out or do whatever I had to do to get them to print correctly. And the result was great. And even better when you could spread out the dots and save ink, because I remember the way I did my driver originally, it was like just completely filling up all the dots, all 144 dots per inch, and it's like you don't need to fill all the dots. If you just want it to be readable, you can get it down to a tenth of that and it's still readable. So save ink. You learn a lot, but it was a fun process. I think with those you had a ribbon anyway, so it wasn't like you Yeah, you used ink, but it wasn't like very obvious because the dots were so small and you're pressing a ribbon, so it's like how small can you really get at that point? Um, but later on when the jets came along, that was, pretty impressive stuff. I worked for a company that did inkjet printers and Brother and Epson and other stuff, and um, I should have, really rolled my Epson printer experience and other things into working for that and gotten some more early embedded stuff to help me with my later 3D printing stuff. But as it turned out, oh, I don't need that. Um, cool, old stuff. Oh, wait, no, this is move. Let's keep that in move. Why not? Um, guy, there we go. Making sure that's clean. Okay, it's clean. Um, yeah, so in general, yeah, all all this kind of like low level experience of knowing how to do bit banging and optimizations at this level is kind of useful for later life, as it turns out. I didn't have all the kind of connections I needed to really work on this stuff and take it to the next level. It was like I was really I was very much on my own and just dealing with the world through the lens of magazines like Compute and Soft Side, and so getting through and learning how to use all this kind of stuff at that time was a real challenge. Fortunately, we had like a computer club, and we pooled our money and got books and discs and games that we could draw our inspiration from. I wasn't really into the piracy for the sake of having games to play them and stuff and building up a big collection. The ones that had cool graphics and effects and I wanted to copy, I would be like, oh yeah, I would like to learn how to do that. And so I would get into that code so that and digging into it as a hacker so that I could understand how to do that in my game. I was much more about the code, and then like the whole club became so much more about software piracy and sharing, and it was like, oh, this is stupid, and I stopped going. Um, but the the hardcore coders, uh, we come back, we come back to this, and it's good to be revisiting this again and kind of taking it as a challenge in a way that at the time when I was doing this stuff as a teenager, I didn't have kind of the discipline to push through and solve a problem, and then of course keep it organized as well. And it was tricky because heck, we didn't even have folders on our discs. You just had a different disk. Oh, this is a folder. This is a folder. So, you only had a certain amount of space on them. So, once like 1.4 megabytes or something, I think. So yeah, we had to work within some constraints, and I could demonstrate things like working on within the Atari macro assembler and stuff, but it's pointless. You just hear me clicking on the keyboard and watch the little cursor move around and see how slow it all is, and the fact that you had to remember keyboard commands and that you didn't have point and click, so you couldn't just select from files. You'd have to be, remember your file names and things, and it was just a real hassle to do. It got much better in the Amiga era for sure, and now of course it's like we're so spoiled now. We have all these things like every emulator we could want, and being able to run these like little scripts that turn our code into demo code and everything is pretty cool. I'm happy with where this is going, and that I'm relearning this, and again, I want to make a few things and submit them to ABBUC. So we'll see where that goes, but I'm learning as I go, and the next tricks are going to be like making sound effects and figuring out good ways to have those be built like as tables of sound data, and then to have them play in the background, either in the vertical blank or wherever. Probably the vertical blank is going to be doing a lot of the stuff that we need to do. Um, Things like keeping track of animation frames and um, taking care of animation between moving between spots on the board and so on. Um, and I have to work out all the details of how that's gonna synchronize and everything. I don't remember how I did it in the original Atari Basic back in the '80s, but I managed to get it all to work. So it wasn't. I guess it wasn't too hard. I didn't really have much of it in the way of like fancy animation. I just like for next loop to the next position, lerping as they say. In this, I'm going to try and make an actual little jump animation and do some fancier stuff and make it look cool. And of course, the fact that I'm making it on this giant cube pile is really just it's to torture the player. The idea was, well, if I like Pac-Man, I should make a giant maze that I can just like play Pac-Man all day in. Or if I like Cubert, I should make a giant cube pile so that I can just keep enjoying that wonderful cube dynamic or whatever. Oops. I think I gotta run it again. There we go. Hello. Boop. Cool. So yeah, this is gonna be fun. Um, wish me luck. The next stage in this is again working out the animation, working out a few other things to put on the board, and then I guess at this point it's almost time to start looking at transferring it over into a full assembly project. Although I do like working within the basic framework for certain things, but at this point it's like what's left, you know? It's setting up a vertical blank. It's not something that basic helps with. Other types of things that I can do with this prototype um, would be like drawing lines and other things on the screen to kind of get some idea of the design. But I can do that in like a some pixel art app and then transfer that work over. So I don't know. We'll see what happens. But for the moment, yeah, it's coming together. Oh, I know what routine I wanted to do next. The text drawing on into the graphics. So we're gonna need to have some kind of font, and we're gonna have to draw it. And the way we typically do fonts on these things is you use, the 8x8 system font and draw that. And so if I were to do that and transfer it into this, it would have the wide appearance, and I'd have three colors that I could use to draw fonts, or four if you count, black on some background. So that's one thing I could do is to have drawing of the fonts, the system fonts or whatever the current font is, in wide pixels. The other way to do it is to draw narrow ones that are 4 pixels wide, and so they're 8 bits but 4 pixels, and those can be cool. So I may actually do both. The cool thing is you can have multiple fonts, and there's plenty of space for them. And if you're only going to use certain characters, you can just double them up inside the font and translate them as you draw them or whatever. So I might go with that. So we'll see how that goes. So that's one of the things I definitely want to do. And the other thing was that color transition animation that I did, so that I would smooth it out. So I ended up jumping straight into drawing the sprites, which is fine, but because I was planning originally to just do that animation, I thought that would be quicker. But we'll do that next, and we'll figure out how to synchronize it with the display and stuff so that we don't end up tearing the display. I think there's a way to like you can set a flag and then wait for it to be cleared by the vertical blank or do other things. And we should probably just set up a vertical blank to get started on that as well. And I already have code that demos that, so I'll just bring that in and we'll build on that. So, all right. As you can see, the project is coming together. Here's our Snorky folder. Let's take a quick peek at it once more. Crossover Snorky ASM folder, Snorky list folder, all the things in there. We have a make file. It's all good. Yeah, there we go. And the pieces are now at this stage a move, init, guy, and cube. And so we'll just keep building out these routines and or transfer them over to our code base. The other cool thing about assembly is you can just copy and paste the code, and you won't have to worry about anything if you put it inside of its own proc like wrapper. Like everything, all the labels and everything are unique to that wrapper. So it's very cool to be able to do that, and then you can just take each of these pieces and include them or whatever and have them in their separate files. So we'll get more organized in terms of the project as we go along and see whether I stick to the basic or do other things. We don't know yet, but keep an eye out for that. Stay tuned. All right. Retro out, people, and thank you for all your support over the years. Let's keep going with this cool retro and rep rap stuff. Love you guys. Bye.